Hello everybody and welcome to another video in the Wanderer series. Today we are going to be taking a little bit more of a dive into the program that is running how the random positions were being controlled that I talked about in the last video. So we're going to kind of try to run through this a little bit quickly. So if you have any questions, please put them in the comment section or message me directly and I can expand a little bit further. But anyway, this is the basic system. So this bit over here, what this is doing is this is creating 8 individual points and then tagging them with a numeric identifier and then listing the 3 points. So to give you an idea of what that looks like, what I'm going to do is just print it off. And it's going to pop up over here. So boop. So here you can see that point 0 is given these coordinates, point 1 is given these coordinates, point 2 these, etc., going down through the list. Now I'm going to tag it once or twice more so that we can actually get a 0 that's not a 0, 0, 0 point. So there's our random points being generated. So moving on from that, what we're going to look at is in here. So what this is doing is this is effectively turning the mouse into the physical user that we would be seeing with the Kinect. I didn't want to run the Kinect for this because it's easier to show you using something like this. So mouse state is just generating the X and Y positions for where the mouse is. I'm using 2 screens, so 1281 is the left-hand side of this screen, 3200 is the right-hand side of that screen, 800 and negative 280. Negative 280 is actually the top, so this one is inverted. And then I'm basically using this to say if it goes below -1, don't report that because there's no reason for us to look at that. I'm then packing it into a system that is 3 digits, the same way that this is 3 digits. And then we are going to send that out and combine it with the other item. And that's going to be in this bit. So in this one, what we're doing is here we're receiving the random point. We're then separating which point we wanted. So here we're saying I want to look at point 0, which gives us this 3-digit point. From this side, this is where the mouse information is coming in. So this is sending in a 3-point list. That is then going in here, which is first triggering this list and putting it in here, and then sending its initial list through to here. Then it is rounding it to 3 points, and then it is generating the full list. So to give you an idea, I'm going to turn that on, wiggle this around a little bit, and then turn that back off, and then we can look and see. So here we can see that the first 3 digits that we get are the X, Y, and Z positions of the mouse. The Y position is always 0 because, again, in this one, we just set it automatically to 0. Then we are getting the X, Y, and Z position for the random point titled 0, which is here, and then is rounded down there. And then that is just all coming out through here so that we can get a 6-digit list to work with. So then we go into the actual calculation. So in order to calculate the distance between 2 points, you can use Pythagorean theorem, which is a squared plus b squared equals c squared. So in order to kind of look at this, to determine, because we've got 3 points, we have a horizontal point, a vertical point, and then a depth point. Because of the way that I've got this set up to use the mouse, it would be as though we're looking top down on the floor where the user is standing. So the Kinect more or less would be up here, and this would be the back of the room, this would be the front of the room, this would be the left-hand side of the room, this would be the right-hand side of the room. So using those straight line coordinates, we can determine how far away something is. So that gives us this equation, which is the Pythagorean theorem. In order to determine how far away things are, first we have to look at the difference between each linear point. So the x coordinates, we find the difference between the x coordinates, then we find the difference between the z coordinates. We square each of those and add them together, which gives us the distance of the two squared. So then we find the square root of all of that, which will give us the actual distance that we're looking for, which is what this equation right here is doing, the x per square root pow information. This is looking at that 6-digit list that we were sending it, that we were looking at just a moment ago. This says, look at the first item of the list, and subtract that from the fourth item of the list, square that, then add that to the difference between the third item and the sixth item squared, and then take the square root of the whole system and output that value. We are then looking at that value and saying, if that value is less than 0.125, then we're going to just output 125, otherwise output the value itself. So I'm going to turn this on, and then we're going to take a look at how that comes out. So first, that's not what I want. I want one of these. First, we're going to look at the actual values that we're getting. So we have this random point, and the closer we get to that point, the closer to 0 we are. So it would be somewhere kind of up in this area. Now, in order to make it an easier target to kind of hit so that we can actually get all the way to a full value, this is saying if it is within this distance, then output that amount. Otherwise, output the actual amount that we're seeing. So if we look at this, whenever we get within that, where was it? Up here. Once we're inside that space, we actually have a little bit of room to kind of move around. And actually, I'm going to show it to you like this. Nope, not that one, this one. So you can see that when we're outside of that space, we're getting the exact same information. But once we get real close, you can get closer, but there's no reason to do that because we're outputting that 125. Then I'm telling it that for as long as it's 125, send out 1. If it gets to 0.05, send out 0. And then outside of that, if it gets below 0, just send out 0, otherwise send out the actual value itself. So to show you kind of what that looks like, so what happens here is if we get too far away from that point, we end up sending out a negative value, which you're seeing right here. And we don't need to be sending out a negative value. Multiplying something times a negative value is problematic. So what this is doing is just saying that if you're outside of 0, just send 0. Don't send any negative numbers. So once we cross over into positive numbers, you can see that we get the same value here that we're getting out of there. But once we're in the negative numbers, we just get a 0 here. Anyway, moving on. From here, we're just sending this information into our volume controller. And the volume controller is in here, which jumped over to the wrong screen. So what we're doing here, and I'm going to turn this off for just a moment, is we're taking a sine wave at 220 hertz, which is just a single tone, and then we are multiplying that by the volume number between 0 and 1 that we are receiving, determined by how far away from that random point we are. This is saying go to this number in 25 milliseconds. Mostly that's so we don't get any really harsh clicks or harsh sudden changes in volume. From there, we are taking the number out here and just multiplying that by the cycle amount, or by the cycle, which is effectively like a volume control. So once we have this running, what we can actually see is as we get close to that point, say there, we can actually see that the volume is being controlled by how close we are to that center point. And then once we're inside that center point, we can be in a relatively decent sized space and still be at that full volume, and then move out and into a 0 point so that we're not sending out any volume at all. So that is how this whole system is working. That is kind of a nitty-gritty, down and dirty version for it. So the whole program, when you look at the larger scale, looks more like this. Here is that same randomized point system that we're using here. This is just determining where the user is and kind of controlling what information is being sent out by it. Basically just converting it into the 3 points, the XYZ position. This is creating effectively 8 individual channels where we have a single sine wave that is being transposed by various amounts and then sent on independent channels A through H. This is our emergency stop, which will be set up with spacebar so that if things go out of hand, I can shut the whole thing down. Here is the multiplication system that I was talking about. This is basically just further volume control and a little bit of delay to give it a little bit more fuller sound. But here we can see the same system where we've got the x per square root power of the difference between the 2 points squared plus the power of the difference of 2 other points squared, scaled and controlled. I showed you a different version. This is an older write-up, and so this will be changing to more accurately reflect the other approach. Here we have the go to this point in this amount of time going into our line tilde, which goes out, and then we have a different controller, 1, 2, 3, 4, 5, 6, 7, 8, for each individual channel that we're kind of looking at. So just to give you kind of a little bit of information, I'll tag this one a few times so that you can see that information then goes in here, and each time we get a new one, we route new information, so each one is different, and those are all 8 of our new points. So that is, again, a quick and dirty version of how the program is running for those random points in space. If you enjoyed this video, please make sure to hit the like button. If you have any questions, please feel free to comment or contact me via social media. I'm really looking forward to continuing on this project. Please like and subscribe to continue on this journey and to keep watching how things progress. And I hope to see you in the next episode, where we will be talking about the mic controller, in which I will hopefully be demonstrating how motion towards and away from 3 or more different microphones will control various effects being placed on those microphones.